So there are different stages of boiling. Okay, you have pool boiling, going to forced convection boiling, then you have subcooled boiling, and then you have saturated boiling, and we'll see each one of these. Okay, now when the liquid is at a lower temperature than the bubble, okay, let's pay attention here. When the liquid is at a lower temperature than the bubble, the heat will be transferred from the bubble into the liquid, causing some of the vapor inside the bubble to condense and the bubble to eventually collapse. Okay, so we are talking about what happens after boiling. Okay, so when boiling happens, remember there are always going to be bubbles formed. This is not like evaporation. Evaporation does not have any, it does not involve any bubbles, whereas boiling does involve bubbles. So we are talking about a situation where bubbles have already been formed, which means boiling is happening, right? And in this case, when the liquid is at a lower temperature than the bubble, okay, then the bubble will condense and it will just collapse. Okay, the vapor inside the bubble will condense and the bubble will eventually collapse if the liquid is at a lower temperature than the bubble. If the liquid is at a higher temperature than the bubble, then the heat will be transferred from the liquid to the bubble, isn't it? Because the liquid is at a higher temperature than the bubble. And this will actually cause the bubble, the vapor inside will start evaporating rather than condensing, and the bubble will eventually grow and it will become lighter and it will go to the top. So this is what you see when boiling happens. When you start heating a container filled with water, bubbles will eventually be formed on the bottom surface and then they'll eventually rise. Why does that happen? Because of this process. This is all pool boiling, okay, where if the liquid is at a lower temperature than the bubble will condense. If the liquid is at a higher temperature than the bubble will expand and rise up. Boiling is called pool boiling in the absence of bulk fluid flow and flow boiling, or forced convection boiling in the presence of it. So there are two types of boiling here. One is pool boiling, where there is no flow involved. So if you have just a container filled with water which is not moving at all, okay, and you're just heating it up, this is called pool boiling. This is what you typically do when you heat up a pot of water at home. Now, forced convection boiling means, let's say you have water flowing in a pipe. Here they have shown it from bottom to top, and you're heating it on the sides. So this means it's actually flowing and it is boiling at the same time. So this is forced convection boiling. Now, pool and flow boiling are further classified as subcooled boiling or saturated boiling, depending on the bulk fluid temperature. Okay, so what is saturated pool boiling, or subcooled boiling? There's a sharp increase in temperature near to the surface, but through most of the liquid, the temperature remains close to the saturation temperature. So subcooled boiling or saturation boiling, here you will see that the water around, okay, is at a lower temperature, but near the surface you have a much higher temperature. Here they have shown it as 107 C, okay, whereas around everywhere else it's like 80 degrees C or 100 degrees C, as in close to the saturation temperature. So there is a sharp increase in temperature near the surface, but through most of the liquid the temperature remains close to the saturation temperature. So can anybody tell me, okay, if you're talking about water here, right, what is the saturation temperature at 1 atmosphere? It is 100 degrees C. That's right. It is 100 degrees C for 1 atmosphere. For different pressures, the saturation temperature is different. So for 1 atmosphere, it is 100 degrees.